I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 10.
Ryan, have you seen any good movies recently?
Good movies. I saw a movie that a lot of people have said is good and that I decently enjoyed.
Oh, that's fun.
Does that count?
Yeah. I'm going to tell you about one that I decently enjoyed.
Okay.
I was watching Bruce Almighty. Have you seen Bruce Almighty?
Long time ago.
With Jim Carrey.
Yep.
He gets God's powers.
Yep.
And
I don't remember why, but yeah.
I don't remember why either exactly, but like he has a lot of emails in his inbox because he's getting everybody's prayers, stuff
That's
like
right.
that.
Mm-hmm.
And he's trying to be all romantic for his girlfriend. So he like lassos the moon and brings it closer. So it's like a really romantic evening with the moon like looks huge and everything.
Yep.
And then the next day there's tsunamis and it's like all these like natural disasters happening with the waves and the tides and everything because the moon is now closer to Earth.
Okay.
So then that's when he starts learning about like his consequences for his selfish actions and everything.
Okay.
So maybe don't bring the moon closer to Earth.
Well, it's interesting that you mentioned that and that you mentioned a movie because in the movie that I went to see, there are these things called trailers beforehand. You've heard of them?
Yes.
Previews for other movies?
Uh-huh.
And one of the ones that played before this movie, there is some sort of disaster movie coming out that the moon is coming towards the Earth and it gets closer and closer. It looks terrible. The science in it looks awful. But yes, there is a disaster movie of the moon getting too close to the Earth. That's
so funny. Well, I feel like you and I should talk about moons. There's moons on your shirt. There's moons in the movies we're watching. And so what I'm curious about today, though, is why does the moon affect the tide?
Why does the moon affect the tide?
Yeah.
That's a really good question. Not that you ever ask not good questions, but it's a good question. And it'll be interesting to do our little pre-assessment with you here in a moment to figure out how much detail do we want to go in to answer this question?
Oh boy.
But let's just start with finding out what you already know. What do you know about how the moon affects? Is it a how or a why question?
Either one. I don't know. Well, it depends on how much time we have and how far we get into it. I'm not sure. We'll say, why does the moon affect the tide / how? No, I want both. Okay. Why and how.
Why and how.
Mm-hmm.
All right.
Yeah.
Based on your current level of understanding, why and how does the moon affect the tides?
Yeah.
No, I'm asking you.
Oh, you're asking me. Okay. Yeah. This is the part. This is not
this
like
the pre-assessment part.
Yeah.
No, this is the part where you tell me.
Are you one of those teachers that asks rhetorical questions?
Maybe. It depends.
Like a thinker. Because that felt like you were going to like, I don't know. I'm going to actually answer your question now. So. You look so confused.
I am so confused. I don't understand what's happening. Okay, let's move on.
Okay. So I know that the moon goes around the Earth in rotations. No, revolutions. It rotates around itself. Does it? Does the moon rotate? The Earth rotates. This is another thing I don't know is if the moon rotates or not. It revolves around the Earth. I know that it looks different at different times of the month, and that is because of how much the sun is shining on it versus how much the Earth is casting a shadow on it. So then it's in different phases. So what I don't know is if those phases have anything to do with tides or not. I know that tides also happen at, like, they go in and out twice a day. I've seen tide charts because my parents used to keep a copy of tide charts at their house on Whidbey Island to figure out like how many feet like above or below zero it would, the tide would be, to see like when can we see the best tide pools. And so that means like you can also predict it. Like you could know, like, I think like a year from now, approximately what the tide would be and what time is going to be low tide and high tide. And if it does have to do with the phases of the moon, then that makes me think that it has to do with the moon's position, because I'm guessing that's why the moon looks different every night, is because of its position compared to Earth. But it's weird that it looks different to everybody because it's like moving around the Earth. So it feels like, wouldn't there eventually be more sun on it? This feels like a different episode, but
yes, it does.
but that makes me think of that. But if it does have to do with this position, then it feels like, does it have to do with how far or close it is to the Earth? Like, is it a gravity thing where then it's affecting like water getting higher and lower? But I don't think the water is getting higher and lower. I think it's just lower and higher at different points on the globe. Like when we have low tide here, do they have high tide in Japan? Like, does the whole Pacific Ocean shift one way and shift the other way twice a day? Or is it like a pressure thing where it's actually going down and up twice a day? But what does that have to do with the moon at all? Like the Earth has gravity. Is it a gravity thing? The Earth's, I don't know. Yeah, I said things that were about the moon and about the ocean. That's what I know.
You did. You said things about the moon and about the ocean. That is true. Well, that was a lot of information, Cheryl. And a lot of the information I'm not going to address in this episode, because a lot of it was things that you talked about the moon, which was actually really good. But I think we might need to do a separate episode, a separate lesson just on the phases of the moon.
That sounds great.
So write it down so we don't forget, I guess.
Okay.
But beyond that, you did say quite a bit about the tides themselves, and you think the moon is involved, but it sounds like you don't quite know how.
Yes.
That's accurate?
Yeah. Mm-hmm.
Okay. Well, one of the very last things that you said is actually the short answer to the original question of why does the moon affect the tides? Gravity.
Okay.
That is the short answer.
Okay.
Gravity. So the moon has gravity, just like the Earth has gravity.
Mm-hmm.
Anything that has mass has gravity. We just don't notice it unless there's lots of it, like a planet or a moon, for example. Okay. And so just like the Earth is pulling on the moon is also pulling on the Earth. They are both pulling on each other.
Oh, okay.
Because the Earth has more mass, it doesn't feel the effects of that pull as much as the moon.
Yeah, that makes sense.
But the moon is affected, or sorry, the Earth is affected by the moon's gravity. And one way we see that are the ocean tides.
Cool.
So I think in order to really explain it, there's a visual part, and I'll do my best to describe it auditorially for those who are listening on the podcast, but also for anyone who wants to watch on YouTube, you can go ahead and watch what I'm drawing, and we'll try to take some snapshots and put those on social media also. So if you're listening, you can look at them later. Does that work for you, Cheryl?
Yeah, that sounds great.
Great.
Love a visual.
All right. So I'm going to start by drawing the Earth.
Oh, look at that little planet.
And then I'm going to go ahead and draw the moon. And I think it's important to note, these are not to scale. So the distances aren't to scale and the sizes aren't to scale.
It's just a little circle.
Yeah. Oh, boy. There, and it's labeled because, of course, I've got to be good and label everything. The short version is that there's, like I said, gravity between the Earth and the moon. And this is going to be an oversimplification, but you can basically think of it as the part of the Earth that is beneath, and I put that in quotes, the moon. That's where you're going to feel the strongest pull from the moon's gravity.
That would make sense.
And so what that ends up doing is, because the oceans are a liquid, you can actually see those effects a little bit more because it's more easy for those to move around, as opposed to a solid. It's more rigid and holds things in more. So it kind of doesn't do that quite as much.
That makes sense.
So what it would probably make you think, which is accurate, is that the water tends to bulge a little bit more when it's, again, quote unquote, underneath the moon.
So it actually like does all go up and all go down in a way.
Yes and no.
Because obviously, like, then on the other side is when it's going down.
No, that's the part that's tricky. And I wasn't sure if we were going to go here or not, but apparently we are. So there's actually two bulges. It's called a tidal bulge because it's a place that bulges in the water, right above, away from the surface.
Okay.
And it's caused by tide. So it's called a tidal bulge. I'm labeling that. Tidal bulge. And by the way, what I'm drawing is incredibly exaggerated. If you were on the International Space Station, you would not notice a difference. The amount up and down.
It's feet.
It's feet under most circumstances. Yes. So you would not see this from space at all. So, but the tricky thing is you would end up with a second tidal bulge on the opposite side of where the moon is, which is counterintuitive.
Yeah. And that's why it's twice a day.
That's why it's twice a day.
Down,
exactly
not
right.
Once a day.
Exactly. And I actually found a couple of simulations that can visually show you this in motion.
Yes.
So let me see if I can pull a few up, and we'll put links to these in the show description and show notes for people if they want to go and play with them themselves. Okay, so here's one. Oops. And so you can see we've got the moon going around, and again, a very exaggerated tidal bulge. And you'll notice how that bulge is following the moon as the moon goes around the Earth, which is revolve, by the way, which you were asking about, rotate and revolve.
I did it.
So rotate is on the axis and revolve is around another object.
And so this is also why it's not, what I'm seeing here also is that the Earth is rotating.
Correct.
And then also, so like, that's why the tide charts aren't the same every day. It's not like every day at 4 p.m. because it's not a perfect twice a day because the Earth is rotating and then the moon is revolving.
Correct.
So it's not going to hit the same times.
Right. Because the Earth rotates once in 24 hours. It takes the moon 28 days to do one full revolution around the Earth. And so it's not going to move that much from one day to the next, but it does move a little bit. So it ever so slightly shifts things. And now I'm trying to remember off the top of my head, I want to say that one high tide from one day to the next shifts by like 40 or 50 minutes each day, I think. I could go look. I don't remember off the top of my head. Here's another thing that you can look at. This kind of was your question about, well, what's happening if it's here on the West Coast of the United States, and is it also doing it in Japan? So if you look here, there's a white mark that shows the rotation of the Earth through those tidal bulges. So at one point, it's at a low tide where it's lower, and then it goes into a high tide when it's in line with the moon. And then when it's at 90 degrees to the moon, it's at a low tide. And then 180 degrees, the opposite side again, that's where that position is at a high tide. Does that make sense? So then,
like, if you go like a quarter of the way around the Earth, like to Japan,
it should be
just like a quarter of a day behind us and what they're
or ahead of us or whatever. Yes. They should be. So when one part of the earth is experiencing a high tide, the exact opposite side of the earth should also be experiencing a high tide.
Yeah.
And anything that would be at a 90-degree angle, if you were to go through the center of the earth, those spots would be where you'd have the low tide.
Yeah. That makes sense. Yes, this visual is so helpful.
I think so.
Yeah.
I think it helps a lot. Now, the tricky thing is, why is there the bulge on the opposite side?
Yeah.
And I kind of feel like we might need a separate lesson just for that, because it can get kind of confusing unless you want to dive into it now.
Okay. I mean, can I get like a very simplified version and then we can jump in?
I can give you the simplified version that's wrong. So I can give you, I know it sounds funny. I can give you the version that you will find if you do a quick Google search, that people will tell you that most people use as the explanation. The problem is it's not technically correct. It's a good approximation, but it's not actually correct.
Okay, that's interesting.
Okay, so why don't I give you that one?
Yeah.
So if you, and let's see how if I can do this here. If we think about forces, right? So the force of gravity pulling on an object. The strength of gravity is determined based on two things: the masses of the two objects and the distances between them.
Okay, so Ryan, that makes sense, because in Bruce Almighty, when he brings the moon closer to the earth, then it has a greater effect on the tides.
Exactly. So if I were on the surface of the earth closest to the moon, it's going to have a relatively strong gravitational pull. Whereas if I was on the surface of the earth on the opposite side, farthest away from the moon, it's going to have less of a strong gravitational pull. Does that make sense?
Yes. And you're still explaining the one that's incorrect, right?
Yes, I am.
Okay.
Well, everything that I've said so far is true.
Okay. But I'm like trying to start putting this in a different spot in my brain where I know I'm learning misinformation.
Well, it's not.
All right, just keep going.
Yeah. So you can think of then the water that's even farther away than the surface of the earth has even less gravity on it.
Sure.
And so the earth is getting pulled by the moon more than the water is, and the water is getting left behind. And that's why it bulges.
But that's what's not true?
That's correct. That is not true.
Okay.
But
I'm kind of glad that's not true, because that sounds like something someone would make up, actually.
I mean, and it's an approximation, because there are elements that are true in it. The thing about the forces, each of those is true. The thing that's not true is that difference in force is not enough for us to see the tides that high.
Okay.
It would maybe make a difference of like a few centimeters, maybe. I don't remember. I'd have to double check.
Feet.
Definitely not. So it's a real, all of the science is true, but that is not what actually causes the tides.
Okay.
Or the tide on the opposite side.
So you're saying that I should not always trust Google?
You can draw whatever conclusion you feel like is reasonable. So we talked a little bit about gravity, obviously. We talked about how they're twice a day because there's a bulge on both sides, right? And how it can be predicted because we know that the Earth rotates. We know the rate at which the Earth rotates on its axis, and we know the rate at which the moon revolves around the Earth.
Yeah.
So we know those pieces.
Yeah.
Now you know the wrong explanation for what causes the bulge on the opposite side of the Earth.
Oh,
and the real reason that there are tides.
Yes. That's really cool. Wow. That's why there's tides.
That's why there's tides. So the basics are fairly simple.
Yeah.
When you dig into it and start really looking at, wait, there's a bulge on the other side, and why is it, and why are they the amount that they are? And there's a lot of things that can make it a whole lot more complex. But if you want to do that, we can do that as another lesson in the future.
I would love to, and I already wrote it down.
Perfect. It's that time, Cheryl.
You would think that eventually I would stop dreading this part of the podcast, but here we are.
And yet here we are. It is
Yes.
time for your pop, not pop quiz. All right. Question number 1. What causes the ocean tides on Earth?
The moon's gravitational pull.
Bing, bing, bing.
Yay!
Okay. Question number 2. Where on Earth are the 2 high tides compared to each other?
Opposite ends, or you could say like 180 degrees away from each other.
Great. Same question, but for the low tides. Where are the 2 low tides compared to each other on Earth?
Same answer, but for the low tides.
Excellent. Nice job. Nice job. Okay. Question 3. Why are there 2 high tides and 2 low tides each day?
Wherever the moon is closest to the Earth is a high tide, but then since it's on the opposite side, and since the moon goes around, like since it's like roughly once a day that the different points in the Earth are near the moon, then like the closest and the furthest away, like you're going to be there. That's going to be your spot on the Earth once each. That was like the weirdest way I could have said that.
Did you maybe mean that there are 2 tidal bulges on the Earth, and during one 24-hour period, one spot on the Earth rotates through both of those bulges?
Yeah.
That's what I thought I heard you say.
Mm-hmm. Yeah.
Just wonderful.
In like very different words that made less sense.
It's okay. It's totally fine. Last question. If the moon was closer to the Earth, a la Bruce Almighty,
yes,
what do you think would happen to the tides, and why?
I think there would be higher tidal bulges. So when it was high tide, it would go up further. Like eventually, like houses would be washed away or things like that. And then when it was low tide, my guess would be it would go lower, but I'm not sure. Like, I'm not sure if it gets more extreme, if the low would be even lower, or if it would just be the same amount of low, like relative to the new high tide.
And why do you think that the high tides would be higher?
Because it's responding to gravity. And so the closer the moon is to the Earth, then like the stronger the gravity is.
There you go. Yes. And your inclination on low tides, because we didn't talk about that directly, is correct. You can think of it this way. If all the water is getting bunched together for a high tide, that water had to come from somewhere.
Oh yeah, that's a good point.
Right.
It's
So
like
it pulls it
segments.
So it pulls away from those sections that are low tides. So yes, when you have higher high tides, you also are going to have lower low tides because there's less water available where you are at the low tide because it all moved over to where there's the high tide.
Got it. Yeah.
Yeah.
Makes sense.
Wonderful. Nice job, Cheryl.
Yay.
See, now you know everything about tides.
No, I don't. That's why in the future, we're going to have more episodes about this because I need to learn about that other weird bulge and then also just more about the moon eventually too.
Yes. And then if you want to get really fancy, I have a really cool way to work in general relativity to explain tides.
Someday we will get there. This podcast pretty much just feels like if you give a mouse a cookie, where like, you know, you start doing one thing and then you're like, oh yeah, that topic. Oh yeah, that thing. And it just like keeps uncovering and leading to more and more. So,
and that, Cheryl, is science.
Oh, is that what that book is about?
Yes.
Yeah.
Definitely.
Will you please read that book to your science class and be like, that's what science is?
Maybe someday. Well, we are just about out of time. So why don't you pack up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.